Okay, so when you're doing domain and range of a continuous graph like this, what you want to do is on the x-axis, since x represents domain, you want to find the farthest left point and highlight the axis to the farthest right point. So your minimum to your maximum. And then when you're looking at this point here, which is your farthest to the left, it is solid, so that will include equal to. And on this side, the farthest to the right is open, so that will not include equal to. So you would then write your domain as -4 is less than or equal to x, which is less than 3. So it's got to be between those 2 points on the x-axis. Then when you're doing your y-axis, same idea, you go from your lowest point on y for range to your highest point on y for range. And then you look and see at that point, is it solid or open? And both of these are open, which means neither end will include the equal to. So this will be -5 is less than y, which is less than 5. And you kind of read those from the variable itself. So for x, you would say x is greater than or equal to -4. And then the other direction, x is less than 3. That means x is between -4 and 3. And then on y, it's y is greater than -5 and y is less than +5. Okay, let's try another one of these. So here we can see that this line has endpoints. This is a line segment, so it ends at -2, -4, and 6, 0. Whereas this one with the arrows indicates that it continues on forever. So when we're looking at domain and range, for the one that has endpoints, you would just, on your x-axis, we would look at how wide the graph is, and this one's open and this one's closed. So we would include the equal to on the 6, but not on the -2. So -2 is less than x, which is less than or equal to 6. Then we would do the same thing for y, how from bottom to top. Again, the top point is closed, the bottom point is open. And so we would say that that is from -4 less than y. So y has to be greater than -4, but less than or equal to 0. Now with this one, the one with the arrows, it continues on forever this way and continues on forever this way. So when we go to write our domain, we could say -infinity to infinity if we wanted to this way, or since it's all numbers, we could just say it's all real numbers. So they may say it's from -infinity to +infinity, or they may just say it's all real numbers. Probably all real numbers is the more common option here. Never actually counted it. Same thing on your range. So this graph with the arrow continues to move down forever and up forever. So we would say that its range is, again, -infinity to +infinity for y, or we would say all real numbers. So either of those. Now, occasionally you'll have one that has an end on one side and continues on forever in the other direction. So more, it's array more than a line segment or a line. And those are a little bit different, so we'll look at some of those. So this one, for instance, is not exactly array because it's not perfectly straight, but it does have an endpoint on one side and it has an arrow on the other side. So if I'm looking at the domain, your x values, then it clearly stops here at -4. It's an open circle, but it goes forever in the other direction. So we could say -4 is less than x, not an equal to because it's open. And that is, we could say less than infinity, or you could just say -4 is less than x. You could just not leave the infinity. You could even write it with x first and say x has to be greater than -4. So since it only has one side that's finite, we could compare to just that one side. Same thing on range here. So this graph, slow point is here at 1, and then it continues upward forever because of this arrow. Even though it stops on this side, the other side continues on. So we're worried more about the continuing on than we are about the side that stops. So we would say that this is 1 has to be less than or equal to, since at 1 it's solid, 1 has to be less than or equal to y, and we could leave it like that, or we could add in the less than infinity. You could even say y has to be greater than or equal to 1, just meaning that your y's have to be greater than or equal to 1. It doesn't have to include both ends of the inequality if one side is finite. Okay, this one I threw in because it's discrete, and so just to kind of refresh with discrete one, you simply identify where each individual point would be on the axis. So this point is at -3, this one's at -2, both of these are at 1, and this one is at 4. And so when you are doing your domain, it would just be the set of those numbers. So -3, -2, 1, and 4, you would not use an inequality. And then same thing for the y's, we would say -4, -2, that point is at 0, this point's at 3, and this one is at 5. So when we do our range, we would say it is -4, -2, 0, 3, and 5. Just discrete, so you're just only having to do those particular points. Okay, so this is another one that's array, and so you can see here on the domain that it does stop at -2, but then it continues on forever in this direction. I'm not going to work through all of these. We did do them on the Pear Deck together, and if you would like, I can open the Pear Deck for you. So this is one here. When you're looking at this one, it looks a little bit different than the straight line, but it still has this arrow moving to the left, so it does continue left forever, and it has an arrow moving to the right, so it does continue right forever. So we would say that the domain of this is all real numbers. Remember, domain is going to be your x values, and range is going to be your y values. That's that Dixie-Royd. Domain is input x and independent. Royd is range, which is going to be your output, your y's, or your dependent variable. So again here, looking at the end of this graph, it's an arrow upward, so that continues on forever upward, and then an arrow down would continue down forever. And so on our range, we would say all real numbers, or it could say -infinity to +infinity with the inequality statement. Now, this one is different because if you're looking at the domain of this, it is only here at 6, and it does have this arrow, but it's going straight down. It's a vertical line. And so that's a little unique with the domain. So I'm going to come back to domain in a second. We'll do range first because range is a little bit normal. This one has a high point here at 15. It's open circle, so we would not include the equal. And then it continues down forever. So we would say that for the range, it's going to be that it has to be less than 15. So we would say this is from -infinity for y, and then y has to be less than 15. Does not include the equal to. You may not include the -infinity, so this could be written as just y is less than 15. And then when we go back to our domain, since it didn't move left or right off of this line, our domain is going to look more like it's discrete instead of continuous. So the domain is actually just going to be the number 6. So we would say that it's 6. You could do it like this. Or you could even just say x equals 6, which is actually the equation of the line because it just always stays at 6. There's no y won't impact that one. That one's a little different just because it's a vertical line. Horizontal lines would be kind of the same issue. If it was a flat line this direction, then it would not change its y value, but it would change its x value. So we would say it's y equals a number, or just that number is its range. And then for domain, it would be wherever it starts and stops on the x. All right. And then this one here, so with our domain, the arrow left and the arrow right means it continues forever left and continues forever right. So we would say for our domain, it's going to be all real numbers, or negative infinity to positive infinity. And then for our range, it turns here, makes this parabola shape. So it's from here upward. And this is solid, even though there's not a point, it's not an open circle. So the only time you would not include the point is if it was an open circle. So this range would be from 0 being less than or equal to y, and then less than infinity. Most likely it would just say that y has to be greater than or equal to 0, so it would only focus on that part and it would read it from the y. So this whole graph is above 0 on the y-axis. Okay, well, hopefully this helps you guys with the continuous graphs. The discrete ones, again, those are just lists of what exact numbers were used each time.